We're going to continue with section 3.1 on functions. We're going to introduce some notation that is unique to equations that meet the definition of a function. These two equations that I have listed here are both functions. They both, for every given value of x, only have one value of y, and we can tell that because they don't have that plus or minus out in front of a square root. One thing we learned about equations in two variables is that y is the dependent variable and x is the independent variable. So we can say that y depends on x, and another way to say that is that y is a function of x. Now, we like to abbreviate things, don't we? We want to write things as short as possible, so we're going to take everything away from this word function except for that first letter f, and then we can say y is a f of x. Now we can shorten that even further by writing y equals f of x. So when we see this notation, this is how we say it. Y equals f of x. And what it means is that y is a function of x. And y depends on x. And the equation is a function. So the biggest takeaway from this is that y and f of x are interchangeable if y is equal to a function of x. So that means that we can rewrite the equations that we've identified as functions by saying f of x equals x squared minus 1 and f of x equals negative 2x plus 3. One of the benefits of using function notation is that it has an x built into it, so if we want to actually plug a value for x into the function, we can use that notation. So we have this function f of x equals x squared minus 1, and we want to evaluate the function at some given values of x. So f of 2, that just means that we are taking x equal to 2. Let's start with that one. So we are going to go x is equal to 2. Remember, that's our independent variable. We can choose what it is, and then the function depends on what it is. Y value depends on what it is. So what we do is we take our function, and it's kind of like it's just sitting there waiting to have something put in. And so what we're going to put in there is this 2. So it's f of 2. And the f of 2 is going to be equal to the function if we replace x with 2. So instead of x, we plug in a 2. So it's 2 squared minus 1. Well, 2 squared is 4 minus 1, so we get 3. So we said that x was equal to 2. We just determined that the function evaluated at x equal to 2 is 3. Remember that the function f of x is also interchangeable with y. So we determined that we had x is equal to 2, y is equal to 3. That gives us a solution, an ordered pair of 2, 3. And if we wanted to graph this, we would plot that point on our xy axis. Now let's try f of negative 3. So we are going to take x equal to negative 3. And in the notation, we can write that as f of, and we can replace that x with what it's equal to, what we're saying it's equal to now. We're saying it's equal to negative 3. And we replace the x with the negative 3. So we're going to have a negative 3, and then that's squared, and we subtract 1. When we square a negative, it becomes a positive, so we get positive 9 minus 1, and our result is 8. And just a reminder that we had x equal to negative 3. We plugged in x to the function, and we got an 8, so that tells us that y is 8. Corresponds to an ordered pair, or a point, negative 3, 8. Okay, now let's look at this next one, f of negative a. Okay, it's not a number, but we're going to treat it just like it was a number. So we have x is equal to negative a. So we plug in negative a for x, so that's like f of negative a equals, and we're going to take that negative a and square it, and then subtract 1. And that's going to equal negative a squared. The negative squared is positive. A squared is a squared minus 1. All right, so we don't get a number in return because what we plugged in was a variable. So that's just a squared minus 1. All right, let's look at the next one. Again, we have no number plugged in for x. And notice that there's a negative out in front of the function. So we want to evaluate this. We want to evaluate negative f of a. So we take our function and we're going to put a negative in front of it. So negative in front of the function, we plug in a for x. And notice there's parentheses around that because that negative applies to the entire function. And now we distribute that negative. So the negative applies to the a squared and it applies to the negative 1. So we end up with negative a squared, negative times negative 1, so that's a plus 1. Okay, the last one, we've got f of a plus h. So we've got this expression that we're going to plug in for x. So just remember that this just means that x is equal to this expression a plus h. So wherever we have x, we just plug in a plus h. So we're going to take that whole expression, a plus h, square it, and then subtract 1. Now squaring that, remember, is multiplying it by itself. So we can FOIL this out. So first times first, we get a squared. Outer times outer, we get a times h. Inner times inner, we also get a times h. So that ends up being 2 of those. And then last times last, h times h, we get h squared minus 1. And we would, at this point, combine any like terms, but we don't have any like terms, so that is our final result. So here's another function, and we want to practice the same thing, evaluating the function at different values of x. So go ahead and pause. Practice evaluating this function, f of x equals negative 2x plus 3, at each of these values of x, 2, negative 3, negative a, the negative out in front of the function, and then x equal to a plus h. Let's start with f of 2. So for f of 2, we are assuming that x is equal to 2. So we rewrite the function notation plugging in a 2 for x and then replacing x with a 2. So we get negative 2 times, replace that x with a 2, and then we add the 3. So we end up with negative 4 plus 3, so that equals 1. And we want to just remember that that is telling us that y is equal to 1 when x is equal to 2. Okay, let's look at f of negative 3. So that tells us that x is equal to negative 3. We can write down our function notation and we plug in negative 3 for x. And then in the function, we replace x with negative 3. So we get negative 2 times negative 3 plus 3. Negative 2 times negative 3 is going to be a positive 6. 6 plus 3 results in a 9. So when x is equal to negative 3, y is equal to 9. Okay, let's move on to this one. So we're going to take x equal to negative a. Let's see what happens. So f of, we're going to plug in negative a. And in the function, we replace x with negative a. So that kind of looks like I put in a negative 9 there you go, negative a. So negative 2 times negative a, that results in a positive 2a. So we get 2a plus 3. All right, so that is our result when we plug in negative a. Now let's look at the next one where we put a negative out in front of the function. So go negative f of x, or it's actually negative f of a. Okay, so we're going to put a negative out in front of the function, and the function is negative 2x plus 3, but we're also replacing the x with a, so it's negative 2a plus 3. And here we just want to distribute that negative. So negative negative 2 becomes positive 2a, and then negative 3 is a minus 3. Last one, we're going to take x equal to a plus h. And so we are going to evaluate the function at a plus h. So we plug in a plus h for x. So negative 2, plug in a plus h, replace that x with a plus h, and then we've got the plus 3. So here we want to distribute that negative 2. So that results in negative 2a minus 2h plus 3. And that is the result. We have no terms that we can combine, so we leave it just like that. Now we're going to look at a function and set it equal to a value and solve for x. So what we want to do here is recognize that we are given that the function equals something. So we have f of x equals 3, so that means that f of x is, well, it's square root of x minus 4, and here it says that f of x is equal to 3, so that means that square root of x minus 4 is equal to 3. So we want to solve for x. So this is opposite of what we were just doing, where we set x equal to something and we evaluated the function and got a y value. This time we're starting with a function value or a y value and solving for x. So to solve for x here, we want to get x out of the square root. So we need to square it, and we square the other side as well. Squaring just takes away that square root, and we're left with x minus 4. 3 squared is 9. We're going to add 4 to both sides, so we get x equals 13. So notice our result is that x is equal to 13. So we didn't start with a value of x, but that is our solution. So that means that when x is 13, y, the function value, is equal to 3. Okay, we're going to do the same thing here. We're given a function value and we want to solve for x. We have f of x equals 15. So we set f of x equal to 15. F of x is x squared minus 1. So we're setting x squared minus 1 equal to 15. So to solve for x, so let's just write that down. That's what we want to do, is solve for x. And to do that, we're going to add 1 to both sides. That gives us x squared equal to 16. Now we want to undo squaring, so we're going to take the square root of both sides. And when we take the square root of 16, we want to remember the plus or minus out in front. So that gives us x equals plus or minus square root 16, which is 4. All right, so that just tells us when x is positive 4 or negative 4, the function value is 15. So for x equal to 4, function value or y is 15. When x is equal to negative 4, the function value or y is 15.